All right, last lesson. All right, so this is crashing. So it leads on from what we've just done with all our activity networks, finding the critical path and the time that it takes for it to do a job, project, whatever you want to call it, and all the tasks in between. So this one's crashing, and as it says there, crashing is changing the conditions of the project to complete the project in a shorter time. All right, so we're interested in a shorter time. That's the key thing from here. So let's have a look at this activity network that I've got here, and I'm going to base it on this one here. So for example, let me change my color here. So I'm going to use black, and so from the black I'm going to do the forward. All right, so I'm going to go forward. All right, so the earliest start time is 0. So let's go around this way. So when we go this way, start there at time 0. The earliest we can start that is 2 hours or 2 later. Then this takes another 4. So that's 6 later. And then another 3. And so that is 9. I'll put the 9 up there. And we'll check around the other way. So it starts at 0, takes 6, so 6 in here. Then takes 7. 6 plus 7 is 13. So the number that goes here is 13. So we can't actually finish the job, even though this might only take us 9 hours to go around here. We can't actually finish the job until this task's finished. So 13 there. All right, so then we'll go and do our backward scanning. So 13 is what it takes. And let's go backwards here. So 13 take 3. So the latest we can start that is 10 hours after the start. Take 4. The latest we can start B is 6 hours after the start. And according to this here, we can start activity 2 4 hours later. All right. Now when we go the other way, 13 takes 7, that's 6. 6 takes 6 is 0. All right, and so we put the smallest in there, of course. All right, so in the forward scanning, the black ones, we put the biggest number in, and our backward scanning, our latest start times, we put the smallest number in. All right, so from that then, we can then get, just see if I can change my color again, I'll then get my critical path. Now remember, the critical path goes through the things that have no float. So the critical path here is around there. All right, so I already said the critical path. So let's change my color back to blue. All right, so my critical path is D to E. All right, so if we want to crash and we want to take less than 13 hours, the ones we've got to reduce is these two, the ones on the critical path, because the critical path sets the time for the whole lot. All right, and this 13 hours, if it's hours, but this 13 is set by these two things, not these around here, because we can already get this finished in 9 hours. So reducing these further is not going to help us. So key with crashing is that it's got to be on the critical path. All right, so what we need to do is to crash or get it done quicker, we need to reduce the time. Ugh, that doesn't look right. So the time for D or E or both, of course. Let's squeeze it in here. All right. So that's what crashing is about. So that we'll get it done less than. So a few notes here. So to reduce the time of project, it's crashing the time. The tasks on the critical path need to be reduced. Changing other tasks will not reduce the time, and I already explained that there. However, the downside of crashing is it comes with a cost, and that cost would be dollars. So more workers, you might have to employ more workers, all right? So 6 and this 7 here, we might have to employ another worker, one to help out here with D to reduce that, and then to help here. That's what we might have to do. Or we might have to pay overtime. So if these are days, for example, this might take 6 days to complete. There's 7 days to complete that. So if we then pay the worker overtime, we might be able to reduce that. So 6 days, giving them to work a couple of hours overtime, or an hour and a half's overtime or something each day for 5 days, and we'll get it done in 5 days. However, as I said, that comes with a cost. All right, so that's essentially what crashing's about. So let's have a look at an example. In this example, we're going to look at, here it is here, crashing example. It's from the 2007 further maths exam, and now there's a slightly different terminology used later on than what we use now, and I'll point that out when we get to it. So we've got a community centre, and we've got to build a community centre. And so there's the start of the centre down here, and then when it's finished the build, and then there's all these tasks during the build. All right, so determine the minimum time to complete this project. So what we first of all need to do is we need to fill out some boxes with stuff in it. So I need to go ahead. Oops, I need to put my pen on. All right, here's my pen. All right, I need to put my pen on. All right, so let's set up with our split boxes. Our split boxes. There'll be one here. I'll put it in here, will I? I'll put it in here. There's one here. Now you're going to need to, and this one here, I'll put this one in here too. All right, so you're going to need to do this before you can do the question. All right, because we need to know these times in this. All right, so start time 0, forward scan. All right, takes 4 hours. Got to start that then. This ton takes 1 hour. If they're hours, no, weeks. 1 week. That one's got to be completed, so 5 weeks after the beginning. 3 here. So that's 8 after the beginning. 6 here. 6 plus 8 plus 6, I believe, will be 14. So I'll put the 14 out there. All right, then let's go some other pathways. So along here. Start 4 hours, 4 here. All right, there's 2 options. All right, I'll go straight across here. If I go straight across here, 4 plus the 4 is 8. If I go around this way, 4 plus the 3 is 7. Plus 4 is 11. So we've got 11 in here. Remember, forward scanning, we take the biggest because we can't start H until both of those are finished. And this pathway around here takes 11 days. So we can't start it until that's finished. Then plus another 2. Now I should have actually put that 8 out here, because then 11 plus 2 is 13, because I've actually not got the right thing, because I can't actually start I until H and G, and yeah, G might take 8, but by the time H is finished, that's 13, so I need 13 in here. All right, and then, so this number there, 14, is not correct, because this 13 plus 6 is 19. Is what it's going to take, all right? And so the 19 actually goes in there. Right, so I kind of got ahead of myself when I got here, and when I went around that way, and I just straight away went when I needed to actually wait here until I've worked out what's going on here. All right, so that's our forward scanning. Let's go our back reverse scanning. Oops. Our reverse scanning, let's change the number, let's make it yellow. All right, so it takes 19. Then when we go back here, that's 13. Let's go around this way. 13 take 3 is 10. 10 take 1 is 9. And 9 take 4 is 5. All right. Now, have we gone this way around here? 13 take 2 is 11. If I go down this way, 11 take 4 is 7. All right, round this way, 11 take 4 is 7. 7 take 3 is 4. And remember, with our reverse scanning, our backward scanning, we take the smallest number. So that's a 4 that goes in there. And 4 take 4 is 0, taking the smallest number, 0. All right, now we've done that, we can answer the questions. All right, let me change my color again. Let's go to orange. Okay, determine the minimum time in weeks to complete the project. All right, there's our answer down here, 19 weeks. All right, next it says, determine the slack time in weeks for activity D. All right, activity D. Here's activity D. So activity D, when we have a look at activity D, the latest it can start is 9 hours. The earliest it can start is 4 hours. So the slack time, or as I said at the beginning, there's a term that we don't use anymore. It's back in 2007. Now it's referred to as the float time, the slack time, float time, same thing. All right, so the latest activity D can start is 9 hours after the beginning. The earliest it can start is 4 hours after the beginning. So there's a 5 hours or 5 weeks. I don't know why I keep talking about hours. There's a 5-week float time or slack time for D. All right, so community builders are able to speed up the project. Some of the activities can be reduced at an additional cost. The activities that can reduce, there they are. All right, so if we want to increase the speed of the cost, so it's got to be critical path, okay? So it's got to be the things on the critical path. So what do I need to do? I need to find my critical path. So let me go and change my thing again, or do the critical path in the crimson. And remember, the critical path is where we have 0 float time. Now we have to go through all the things that have 0 float time. So 0 float time, that's got a float time, so we're going this way. All right, we could go straight to there, but we've got to go through all the things that have this 0 float time. So we've got to go around here, and along here, and to there. So in that crimson there, that's our critical path. So activities that can reduce to these ones, which would not result. All right, tricky, not. So they've used the word not. So the ones that do speed up the project are on the critical path. The ones that don't are off the critical path. All right, and of these ones here that are on the critical path, let's have a look. B, C, F, H, and I. So C is on the critical path. Now we're looking for things off the critical path. C is off the critical path. F is on the critical path. C is on the critical path. G is off the critical path. So which things could reduce the time? These would not reduce the time, not result in earlier completion, would be the ones that are not on the critical path, and that's A, E, and G. All right. Now, let's see. The owner of the estate is prepared to pay for early completion. So the cost of reducing of each activity is $5,000 a week. So we can reduce these here by 2 weeks. Now we've already said in the previous questions, the ones that will reduce are the ones on the critical path. So that's C and F. So we can reduce C and F. Then we can reduce the completion time. So let's go back and have a look at C and F. All right. So we need to reduce C and F. So let's have a look. So these two here are the ones we're going to reduce. And we can reduce them by a maximum of 2 weeks each. Now, what we've got going on up here, across to there, is we've got this, let me change my colour. Oops, wrong. Don't want that. Let me change my colour. Let's go green, shall we? All right, so what we've got here is when we go across, we're here and we've taken 4, and when we go across to here, we take another 4, so we've got this 8 here. And around this other way here is 11. All right, so we can reduce these. Now we're told we're allowed to reduce these by a maximum of 2, so let's go that to 1. Let's go that to, oops, F, let's go that to 2. So what I find then is if I do that, what I end up with is this. That reduces to 1. So 4 plus 1 is 5. That reduces to 2. 5 plus 2 is 7. Which is all very well. But this across to here is 8. So what I need to do, and I can reduce E as well, is so this is where this one's tricky. If I reduce E by 1, crash E by 1, I've then got 4 by 1 to 3. 4 plus 3 is 7 that way as well, and so I can get that time down to 7. All right, so normally, as we're saying, it's got to be on the critical path. But in this case, where they've added a bit of extra complexity, is if you reduce the critical path ones by 2, you then need to reduce this one here by 1 so that it all fits in. All right, so what do we got? Determine the minimum time in weeks for the project could be completed now. So it completed now, 7, we got 7 there, 7 plus 2 is 9, then up to here 9 plus 6 is 15. All right, so this is a tricky question. So 15, so if we reduce C by 2, F by 2, and then E by 1, then we can have 15 weeks. All right, so then determining the minimum additional cost. So the additional cost, so we got C and F. So C, that's 2 weeks at 5,000. F, we got 2 weeks at 5,000. And then we've got E, which needs to be reduced by 1 at week at 5,000. So that's 10,000, 10,000, 5,000, which gives us a total of $25,000 extra it's going to cost to get a time reduction of 4 weeks. All right, we get a time reduction of 4 weeks, but it costs us $25,000 because we're not reducing tasks by a total of 4 weeks worth. We've actually got a 5 weeks worth of reduction in tasks to get a 4 weeks reduction in time. All right, so as I said, that's quite a tricky question. So as always, actually that's the end. So I should have my party poppers. Yay, last one of the year. So we're now finished all our further maths course. So I should have a party popper. Yay! All right. And as always, have fun. And if you need help, get back to me.